Morning class. Today we are going to discuss about worksheet number 42, which is on law of conservation of momentum. This law of conservation of momentum is based on Newton's third law of motion. According to this law, the sum of momentum of two objects before collision is always equal to the sum of momentum after collision if there is no external or unbalanced force acting on them. Or we can also say the total momentum of two objects is unchanged or conserved by the collision. We can also understand it with the help of an example. When a gun is fired, then it exerts a pressure on the bullet also, and the bullet gets accelerated in the forward direction. And before firing of the gun, the bullet and gun both are at rest. Therefore, the total momentum of the system is 0. But after firing, the bullet and the gun both come into motion due to the force applied. So they oppose this force and try to be remain at rest or try to make the momentum 0. That's why when the bullet is fired, the gun moves in the forward direction, and the when the bullet is fired from the gun moves in the backward direction and the bullet moves in the forward direction in order to keep the momentum 0, because before firing the bullet and gun both were at the rest and the momentum was 0 or conserved. So after firing, they tend to remain at their position of rest. So next is equation of law for conservation of momentum. For this, we suppose there are two balls A and B having velocity ua and ub. So at time t, they both get collided with each other after time t, and their velocities changes to va and vb. Yeah, that means initial velocity changes to final velocity. So the momentum of the first ball is ma ua and ma va, initial and final velocities of ball a, and initial and final velocities of ball v b, mb, ub, and mb and vb. So the rate of change of momentum, that is force when they collide with each other, then there is a force acting between the two balls. The ball a exerts force on b and ball b exerts force on a. When ball a exerts force on b, then it is called fab, and when ball b exerts force on a, then it is called fba. So for that, the rate of change of momentum is written as fab and fba for both the balls. That is rate of change of velocity into mass upon t, ma va minus ua upon t, and mv vb minus ub upon t. So this is the equation for change of momentum. Then after that, according to third law of motion, the force act on each other. The two bodies exert force on each other, but in equal and opposite direction. So according to that, fab is equal to minus fba, and then we put the values this one in equation this, so we will get this thing, and after solving it we will get this thing. So it clearly shows that the momentum of the two balls before collision and after collision remains the same. So it is proved by this equation. So you also have to learn this equation and derivation of this equation, because it is asked so many times in your exams, so you have to learn this. And then we go with the questions asked in the topic. The law of conservation of momentum, we have discussed it earlier. Why does an air-filled rubber balloon swings here and there when air escapes from the mouth of it? You can also answer this question now. Why a rocket moves in forward direction in ignition? So you will have to do all these questions according to your own